way in which heat can be transferred, we can move heat, is the idea of convection. And convection occurs in a fluid. So by a fluid we mean a liquid or a gas. And unlike conduction, this actually relies on the particles themselves moving. So for example, if we have a window, and inside your window you're paying money to have your room nice and hot. You've got a nice hot room with a window, and sitting outside the window is a bunch of air. Okay? This is what's called outside, for those of you that spend all your time inside on your computer. This is the inside. If you go on the other side of the door, you get into this amazing place called outside, and it has air and can be quite cold. And in the air, there's a lot of molecules of air dotted around in the air. And what happens is that the heat goes through your window. So through here you get conduction, like we talked about last time. So the glass is a solid, so the particles in the glass don't move around, but they transfer the heat from one side to the other. And so the outside of the window warms up. And then what happens is that the molecules that are closer to that warm up. The ones that are nice and close into the window get hot. And as they get hot, they get less dense. There's more room, they jiggle around a bit more, and there's more room between them. They get less dense, and this causes them to rise. So the actual particles physically start to go up. And as they go up, the other particles underneath them come in to fill the space. So the colder ones come in to fill the space, and of course then the cold ones rub up against the warm window, and they warm up and they go up, and more cold ones come in to replace them. So you get this actual physical movement of particles. Okay? And this is what we call convection. So convection requires particles, molecules that are free to move. And as they get heated up, they shift and they get replaced by more cold ones, and you get this whole motion going around. And if it's a closed space, as they go up, they'll cool down and they'll drop, and it'll go around. But the idea is that the particles, the molecules themselves, actually move. And that's the key difference between conduction, which happens through a solid, and convection, which happens in a fluid. So in this case, a gas, but it's just the same thing happens in a liquid. So when you boil your jug or cook water in a pot or whatever it is, you have your pot, you put it on an element. So here's the element that's nice and warm, and inside your pot you've got all these water molecules floating around. The ones that get down the bottom get warmed up. Same thing, they get less dense, they get pushed apart a bit, so they start to rise. And as they rise, there's clearly a gap left at the bottom, and the cold ones come down and replace that. And you get the whole water moving around and around inside the pot, and the whole thing warms up as the heat goes to the top and is replaced for cold ones to get warmed up. Okay, so this is the idea of convection. And just as we had a formula for conduction, so we have a formula for convection, which is Q equals Ka delta T. Okay. Looks similar to the previous one. Q is exactly the same as in the previous one, so Q again is the rate of heat transfer. A is the same as the previous one, it's the area of contact. So in the window example, it would be the area of your window. In the pot example, it's the bottom of the pot. Doesn't really look like it, does it? It's a pretty crappy diagram. Making it better, getting somewhere. Poorly, yeah, improving every moment. There you go. So the area would be the area of the bottom of the pot. So the area that the fluid is in contact with. So this is the rate at which the fluid takes the heat away from the solid surface. So it's the contact area between the solid surface and the fluid is the area. And delta T, once again, as usual, is the change in temperature. So the temperature difference between your solid surface and your fluid that's taking the heat away. And K is the convective heat transfer coefficient. Convective heat transfer coefficient. Okay, so this is a measure of how effectively the fluid removes the heat from the surface. And that's going to depend on a number of factors. It's definitely going to depend on the nature of the fluid, so water will take it away at a different rate than air does. It's going to depend on the velocity of it, so how fast it's able to move, viscosity, things like pressure, a whole lot of things are going to affect those. So it's not a set number for a set fluid. It does depend on what's going on. So, and again, you can look those things up in a table, and that'll enable you to calculate how much heat is being dragged away from the surface. But the key thing is that for convection, you must have molecules which are free to move. So the heat is transferred by the molecules actually moving and taking that heat away with them. Unlike in conduction, where the molecules stay put, but they pass the energy from one to the other. It's the key difference between convection and conduction. Okay? Convection.